Hi there, John Moore from Eder Engineering. We're here today to talk to you about a stainless steel version of our gas booster that can be used for sour gas applications such as landfill gas, digester gas, some of the more corrosive applications that are becoming very popular now. They're green applications because they're utilizing basically an off gas as a fuel. Why do we need to go to the extent of creating a stainless steel gas booster? Well, there's basically two common approaches right now on the natural gas booster manufacturing for sour gas applications, corrosive applications. One approach is to coat all the wetted surfaces internally of the gas booster with an epoxy coating. The issue with the epoxy coating, it's economical. It's a very economical approach, okay, because you're manufacturing your gas booster completely out of carbon steel and its normal constituents, and then you're taking all the wetted surfaces, putting an epoxy coating on them to act as a barrier for that corrosion so that you don't incur that corrosion on the carbon steel parts. The issue with that is any scratch in that coating, whether it's in the assembly process or whether it's in the transport process or just in the operation of that equipment over time, will act as a root failure and allow corrosion to partake right on that scratch. And from there, once the corrosion penetrates that barrier, basically the corrosion is going to take over. What's corrosive in these gases? Well, landfill gas and digester gas have a very, very diluted constituent of H2S, H2S, hydrogen sulfide. That hydrogen sulfide, when combined with moisture, which from a digester or a landfill are always present, when it condenses, you end up with a very diluted version of sulfuric acid, okay? And that is the corrosive constituent. Now, you know, people say, well, there's only several parts per million of H2S. That's all it takes, okay? Because over time, what's going to happen is you're going to create more and more condensate of this sulfuric acid in the booster. So we're here to tell you, A, we've gone what we feel is the prudent engineering practice, and that is, rather than just coat our carbon steel and hope to protect it through these applications, we've actually gone through the process of manufacturing our booster in stainless steel. Is it more expensive initially? Yes, okay? But the positive side of that is you're making your investment once. This is an expensive piece of equipment. Therefore, you know, you don't want it corroding day one in operation. So in designing around the condensate issue, one of the things we did want to do is, unlike the other booster manufacturers, we wanted to ensure that we could do our best at removing whatever condensate was occurring inside the booster. So what we've done, as you can probably see, is we built this booster. The housing here is at a slight incline, okay? It's tilted down, and that's to allow the condensate to run to this end of the booster so that we can put a condensate trap connection on it. What was important is we want to work with our contracting friends. We want to make sure that both the inlet is plumb and the outlet is level to house piping and to your concrete pad, your housekeeping pad, and what have you. So it's just, in fact, the booster itself tilted. This nozzle is tilted, but when we connect our flanges on, we take the time to make sure that everything's plumb and level. We've done that to make the installation that much easier. So let's zoom in a little closer now, and we'll take a look at actually how we get the condensate out of the booster. So what we've done here is the slope of the tank housing comes this way, and all the condensate is going to ride down to want to pool here at the end of the tank housing, at which point we provide a stainless steel plugged connection that can be run off to a condensate line and a condensate trap. And again, here on the housing of the scroll, this is what houses the fan wheel, which is internal here. This has a second low spot, of which we have put a second condensate connection, okay? So these two ports can be run off to a common condensate trap. One of the things we do in our call out for our housekeeping pad is we ask that the housekeeping pad for the stainless steel boosters is extra high, okay, to allow some vertical drop to the condensate traps and allow proper trap operation. So that's what we've done to ensure that we're getting the condensate out of the booster and not letting it sit. So in conclusion, regarding digester gas boosters and landfill gas boosters, Edder Engineering's taken and tried to take care of your gas booster and its long life in your application by giving you only the best materials and approaching it with a stainless steel construction. One of the things that is important about digester and landfill gas projects to know is that the gas constituents, we need a full estimated or projected gas constituent makeup of your gas so that we can determine the specific gravity of your gas. The gas booster's compression and its ability to make pressure is highly dependent on the specific gravity or the density of your gas. And from that density or specific gravity, we can then calculate exactly what your booster performance would be. So we thank you very much for your time today, and we hope you've learned a little bit about Edder Engineering and our stainless steel gas boosters. Have a good day.